Hey guys, welcome back to Coding Cabin, and in this lesson we're going to be learning about operators, and we're going to be showing how operators teach you how to perform mathematical, logical, or relational operations on data. Now that may have just sounded like a bunch of words to you, but don't get scared, we're going to learn basically all there is to operators. So the first type of operator that we're going to learn is basically arithmetic operators. Now, you may remember from math class like arithmetic, which is basically your addition, your subtraction, multiplication, division. Python has these features because math is strictly very important towards programming. So let's look for example. If I want to output, I can go print and say, let's do addition first. So let me pick two numbers. We'll do 2 and plus 5. So I'm actually going to add a comment, and a comment is basically something that can teach me or I can look back to later to see what this line of code does, and it's not read by the compiler at all. So the way to do that in Python is that I use the hashtag, and I could say this will add 2 and 5, which will give 7. Cool. Now let's run this. Excellent. 7. Nice. Now we can do subtraction as well, just like we did addition. So let's do that exact same thing. So this will subtract 2 and 5. I'll just say that. Look, -3. So it does it in negative. If I were to put 5 minus 2, 3. Cool. The next one is multiplication. So I can multiply two numbers. So 2 times 5. So this will multiply 2 and 5. Nice. 7, 3, and 10. And the last one for arithmetic is division for the basic arithmetic operations. Print 5 divided by 2. Actually, we'll do 6 divided by 2 because that'll be even. 9, 6, and 2. So it gives 3.0. So the reason it gives 3.0 is because whenever we use a single divide, it's going to give a decimal value. And that is because, say for example, just as I had before, say it was 5 divided by 2. It will give 2.5. So whenever it does 6 divided by 2, the single divide will give me a 3.0. It will add that additional 0.0. Now, these are the basic arithmetic operations that you learn in school, and they're very, very useful, and you'll be using them all the time. Now, let's go into some more intricate type of stuff. So we're going to start off with the different types of division. This is the first type of division. So this division is simply just called like normal division. And this just divides two numbers and it gives the result. If it's not even, it'll give the decimal as far as the decimal goes, or as far as the computer can handle that decimal, or as far as you set that decimal to go. Another type, which is an extremely useful type of division, is something called modular division. So I'm just going to show you an example and maybe we can work out what it does. 5 and then you go %2. So that's 5. You would read this as 5 mod 2. Let's run this. So, we get 1. What type of division is this? So I'm going to put modular division. So what type of division is this? Let's think. Well, I know this, but maybe you realize that whenever you do 5 divided by 2, 1 is actually the remainder of that. So whenever we did division using paper, pencil and paper, and we put the bracket or the number inside, then we put the number on the outside, and then we went, okay, how many times does 2 go into 5? Cool. It goes in 2 times. Then at the bottom we would subtract 4, so we'd get 5 minus 4, and that's left with 1. Now I know that's very difficult for some people to conceptualize, so we'll just do a few more examples. So print 6 mod 2 0. Now the reason we get 0 is because these evenly divide. If I were to put a divide here, it would give me 3.0 as we figured out earlier. So whenever it goes for the remainder, there is a remainder of 0. They evenly divide. And that is really important to understand. So let's look at something else. Say we had 4. 2, right? 4 goes into 6 one time, and then 2 left over. That is the remainder. So let's look at an example where the first number is smaller than the second number. So 4 mod 6. So, we get 4. That makes sense. 6 goes into 4 0 times with a remainder of 4. There are 4 left over before 6 can go into 4 once. Now that may have sounded very confusing for other people, they may have gotten it. But basically if the number on the left is smaller than the number on the right, it will be this way. It will be 0 and the remainder will be whatever the number is. So that's what modular division is. Now I am going to show you another form of division, which is floor division. And floor division is really, really useful if we were doing something like this. So say we have 5 divided by 2. This gives me 2.5. Now I don't want 2.5. I want it as an integer. I don't want any decimals. I don't like those decimals right now. So in Python, I can add an extra slash, and this is called floor division. Basically, it's flooring that number. So it's removing that decimal as if it just didn't exist. So if I run this, look, it's 2 here and it's 2.5 here. So it will just round down. If we have something that divides evenly, this will just simply output it evenly. If we have something that doesn't divide evenly, it will just round down. So 7, 3. So this will be 2. So that's what floor division is. The next one we have, so those are all 3 types of division. And the next one we're going to learn is exponents or exponentiation. However, there's one thing I'd like to show quickly before with modular division. This is extremely useful for doing one thing. These examples that I showed you where I mod something by 2, if anybody picked up on it earlier, great. If you didn't, also great. Don't worry. I'm going to tell you what it is now. But basically, if I mod something by 2, that just tells me if something is even or not. So let's look at that for example, right? If I do 6 mod 2 compared to 5 mod 2, 1 is 0 and 1 is 1. 6 mod 2, 6 is even because it outputted 0. So that is extremely important to realize, that I could use mod 2 for mathematical purposes, as in I could tell whether a number is even or not. 5 mod 2 gave me something that wasn't 0, whether it be 1, 2, 3, 4, 5, 6, but obviously it can't be those numbers, but it gave me something that was not 0, which is really important. So basically, another thing to realize with these arithmetic operators is that PEMDAS rule still exists. So if you remember in school, PEMDAS, which was in our school where I was taught, it was please excuse my dear Aunt Sally, or parentheses, exponents, multiplication, division, addition, subtraction. Basically, Python still follows those rules. And if you haven't learned these are basically the rules in which you do mathematical operations. So for example, I have print 2 plus 5 times 3. Now, some people may get confused and say, okay, 2 plus 5 is 7, 7 times 3 is 21. And they'll be like, okay, the answer should be 21. No, that is not how it works. Instead, it will do the multiplication first, which is 5 times 3, 15, and then we'll add 2, which is 17. Sorry about that. Another type of operator that we will learn is assignment operators. So these are all of our arithmetic operators. So I'm actually going to comment this out at the top. Arithmetic operators. And we're going to go down here, and I'm going to do assignment operators. And just because I don't really feel like having all those prints. I'm just going to comment all of this out, which means that these will not print. But assignment operators, or that these are now considered comments rather than actual Python functions. So assignment operators, we've already learned one of them, and that was in the variables video. If I go name equals Ceph, or I can use numbers, we'll go number equals 5. This is an assignment operator. I'm assigning number to 5. So assignment operators are basically just used to assign values to variables. So another thing I can do is this. I can write number equals number plus 1. Now this may look extremely confusing. You're like, what is going on, Ceph? I have no idea what's going on. So let's run it and see what happens. So let's see where it is. Oh, a little error there. My bad. We're not outputting number 6, right? So let's think about what this does. Remember how in the last video I said that we can change variables at any given point. So let's look what this does. So we're saying number is equal to 5. In memory, number is equal to 5. Then we are reassigning the value of number to, what is number? 5 plus 1. So 5 plus 1 is 6. Nice. Now if I were to do 5 plus 6, this should be, you got it, 11. Nice. Now there is a way that I would consider shorthand to write this, and that is what is considered a assignment operator. So I can do plus equals 6, and this does the identical thing to what that previous line did. This is identical to number equals number plus 6. Identical. Now, just as we had addition, subtraction, multiplication, division, I can do the exact same thing. So right here, I will actually erase this line. And right here, I can do subtraction. So let's see what this will get. What is 5 minus 6 is negative 1. Nice. What is multiplication? 30, right? 5 times 6 is 30. So number equals number times 6, which is number equals 5 times 6, which is number equals 30. I can divide. Cool. 0.8334. So that's 5 divided by 6. Nice. So those are the assignment operators. I feel like these are fairly easy to understand, and you'll get a much better grasp as you go through the problems that we have. There are other ones, such as the modular division. So we can do modular division equals 5. Just as I said, if there's a smaller number modding into a bigger number, it will just be the smaller number. It is, let's see, there is the double or floor division. And there is this. Now, you're thinking, what is this? We haven't covered this yet. We didn't look at any arithmetic operators. I saved it until this moment only so that we could just combine these two to get these two ideas together and see if we could learn this way and maybe apply both of our knowledges together. So let's look. Actually, I'm going to choose a much smaller number for this. I'm going to choose 2. So when I output this, 25. Now those of you who are maybe very quick at understanding or quick at interpreting math, you can maybe learn that this is squaring 25. Now, exponentiation in Python is simply done by 2 asterisks. So I can go 5 squared, that'll give me 25, and it'll do 25 twice. 5 cubed will give me 125 and 25. So this is how exponentiation works, and that's how it works on this. So that is basically what an assignment operator is. I'm going to comment this out now. Actually, I'm just going to remove everything now as we move on to comparison operators. Now, comparison operators are extremely important. Now, what are comparison operators? Now, let's think about it. Comparison operator has the word compare in there, and operator, which we just know is any symbol or something that can be used to compare two values. So, what is a comparison operator? It compares two values. Alright, what does that mean? So, I'm going to print 5. Now, you may be like, okay, you put an extra equal there, Seth. You messed up. No, actually, equals is going to output true. Now, this is something that we will cover later as to what a true and a false are. These are called Boolean types, but these are extremely important. An equal basically tests if something is equal to the other one, compared to just a one equal, which is assigning something else to something. Equal means, alright, is 5 equal to 5? Just like, is 5 equal to 3? Nope. So it's going to be false. Extremely important to understand that equal. And just as there's an equal, there's also a not equal. Alright, what does not equal mean? Okay. Basically, imagine that whenever we had this outputted false. I'm just going to say false here. This was false. Okay. If I do not equal, which is 5 exclamation point equals 3, this will basically do the opposite of whatever was here. So that means it's true. Now let's look at what's being said here. Is 5 not equal to 3? Yes, 5 is not equal to 3, so that's obviously true. Cool. So that's what a not equal is. It's an exclamation point and an equal. Now, this is something else that is very useful, these ones. For example, is 5 greater than 3? Let's run it. You don't need these spaces at all. It'll still work. So, true, right? 5 is greater than 3, so it's true. Is 3 greater than 5? No, it's not. 3 is not greater than 5. Alright. Is 3 less than 5? Yes, it is. 3 is less than 5. So this is true. What else do we have? We have greater than, we have less than, we have equals to, we have not equal to. Do we have, oh yeah, print 6 is greater than or equal to 5. So remember in math, if something is greater than or equal to, if I put in a 6 here, this will be true. Compared to if I put in, is 6 greater than 6? No, it's not. 6 is not greater than 6. This will return or print out false. Is 6 greater than or equal to 6? Yes. It is equal to 6, so it will work. Just as if I have this print is 6 less than or equal to 6. So basically, the less than and greater than, the greater than and equal to, or the less than or equal to are extremely similar. It's just one includes the value and the other doesn't. This is something in math that we learn. So those are comparison operators, and these are extremely important. These false, true, true, false, true, true, or these true and false values are extremely important to coding, and it's really important that we get a good grasp of what they are. Now, let's move on to what a logical, actually, I'm going to keep this on here. Let's go to what a logical operator is. So you're like, logical operator? What's that? Now, it's just operators that can combine two or more expressions together. So let's look at this for example, right? So when we had the print, we could say, alright, is 3 greater than 5? Alright, this should output. I'm actually going to comment all of these out so we don't have, it's not as hard to see. We're going to print 3 is greater than 5. False, right? Okay. And we can use the and we can do 3 is less than 7. So this is true and this is false. So this is false. Okay. What does that mean? The AND operator means that it will return true if both the first and second, or however many consecutive ones you have, and 6 is less than 7, or however many consecutive ones you have, are all true. And is something that you want both, or you want all of them to be the way that they are. All of them have to be done to make you happy. And that is what AND is. All of them have to. Compared to if I were to have OR. So OR is like, I would be happy with this or that. If you get that or this, you'll be happy. If you get both, you'll be just as happy as you were with one of them. So in this example, it will be true, right? 3 is not greater than 5. That is false. 3 is less than 7. True. Nice. And 6 is less than 7. True. Perfect. I am just as happy as I was with 3 is less than 7. And I can even prove that. I can remove this. Look, the computer is just as happy. It's true. It's just as happy. It's returning true. It's not false. So this is what logical operators are. And there's one last one that we have to go through, which is basically just not. And to use not, it's nearly identical to what the exclamation point did. So if you remember, the exclamation point, it just changes what it is. So if I go not, and then you need to put it inside of parentheses if you're doing two things. So not 5 is less than 7 is false, right? So 5 is less than 7 is true, and not true is false. So that's how nots work. Those are extremely important operators for logical operators. And the last type of operator is in. So if something, it's very hard to conceptualize what in is without learning stuff that we will learn in intermediate Python, but it's good to just get a basic grasp of what it is. So, So I'm going to go here and I'm just going to type it out. So these are called membership operators. And basically these are used to test if something is in something else. So a way I could do this is basically just putting this, okay? If the character A in A is the character A in this. Yes, there's actually 4 of them for this example. If I change this to this, there's 1. It will return true. If I do this, this will return, or output, or return, this will return false, because A is not in CSDF. So that's what in is, and just like we've had not for this, we can also have a not in this. If A not in CSDF, true, because A is not in CSDF, so it is the opposite of false. So since A is not in here, it will originally return false, but since it's not, it will actually return true. So if I were to, this is just like pseudocode, I guess you could say, code without really like printing it. If I could go like this and put this in here and then cut this out and go like this, run it, let's see what happens. Oh, so false and true, right? Excellent. So those are basically what operators are, and I know this is a really long video and there was a lot of material, so don't be ashamed or don't be scared to watch this over a couple of times to really get a good hold of the material. And if you're still a little confused about something, I'm sure that the problem sets down below will really help you solve the problems out, and if not, we will continually use nearly all of these operators throughout the rest of our curriculum in intro and intermediate and advanced Python. You will continue using it until you have a good grasp on it. Thanks.